Good afternoon, students. Yeah. So last Thursday, we discussed a data cleaning technique, which is a pre-processing technique for handling the noisy data and filling the missing values. Okay, we discussed different approaches for filling the missing values and coming to handling the noisy data. Yeah, let me show those techniques. I'll just revise this data cleaning and then we'll switch on to data integration. Yeah. So these are techniques for handling the missing data. And next, handling the noisy data. One of the technique is binning. So binning is, it smoothens the sorted data. First, it sorts the data. It works on the sorted data, the data which is in an order. So it divides the data into different bins, and then based on the bin mean or its median or its boundaries, the values will be smoothened. So partitioning, we have two types. One is equal frequency and another one is equal width. We already solved this problem. Yeah, in case of equal frequency, every bin will be having equal number of data values, equal frequency. It's also called as equal depth. And another one is equal width. In case of equal width, we set the width of the bin. The number of data values may vary from one bin to another bin, but the width will be same. So width will be in such a way that the first bin width is set to min plus W. Minimum will be the lower boundary. The higher boundary of bin 1 will be minimum plus width. And the second bin will be minimum, the end of this, that is minimum plus width. And next, minimum plus 2 into width. Minimum plus 2 into width. Okay. In this example, we already solved it. Bin 1 width will be 10. So width is calculated based on the maximum value, difference between the maximum and min value divided by number of bins. So in our example, we have width as 10. So how bin 1 width is set as, what is the minimum value in the overall data? 4 is the minimum value. So 4, and next it's width boundary will be minimum plus width. What is that? 10 plus minimum value, that is 14. So yeah, wait a second. So W is maximum minus minimum divided by number of bins. So it is 10, width is set to 10. And now we have to partition this data based on this width. So that is partitioned according to this criteria. Minimum is 4. So minimum plus W, 14. So this is bin 1 boundaries. So all the data values from 4 to 14 will be in bin 1. And next values from 15, the next value, 15 to minimum plus 2 into W, that is 4 plus 20, 24. So this will be bin 2. So this repeats until the last bin. Here we have only 3 bins. Okay. So this is equal width binning. So based on the question given to you, whether it's asked to solve the problem using equal frequency or equal width, you have to read that, and then according to that, you have to solve the problem. Yeah, so this is an exercise. You can do it. And next one is a regression. Regression is also one of the, please mute yourself. Yeah. So in case of regression, we discussed a simple linear regression. So yeah, so this method also used for handling the noisy data. Actually, we know linear regression is used for a prediction. Okay, so how this prediction modeling technique is used for handling the noisy data? We discussed with an example. So this is the example. So here we have two variables. One is a dependent variable, which is tip amount, and another one is the independent variable. Okay. And now, based on the two attribute values, these are the data points plotted on this graph. Now we have to develop a model, a linear regression model, such that it will fit best to all these points. Okay. There may be multiple lines passing through these points. We have to select a line which is closest to all the points. And one of the simple method for checking whether it is a best fit line or not is the line which passes through the centroid will be a best fit regression line. So what is the centroid here? Average of bill amount is 74 and average of tip amount is 10. So if the line passes through this, then it will be treated as the best fit regression line. Yeah, so according to this least squares technique, we build a regression model. We find out the regression coefficients B0 and B1. So once we find B0 and B1, then y equal to B0 plus B1 into x will act as linear regression model. Yeah. So this problem we have solved. This is the numerator. What is the numerator here? So this one, sum of the products. Product of deviation of each x from its mean x bar, deviation of y from its mean y bar. Sorry. Y bar indicates mean of y, x bar indicates mean of x. So you find out the deviations and the sum of the products will give the numerator, and then the denominator is the sum of the deviations, squares of the deviations, sum of deviation squares, sum of the deviation squares. So that will find, that is 4206 and the numerator value is 615. So you'll get B1 as 0.1462 and now B0 will be calculated using mean of y minus B1 into mean of x, which is minus 0.8188. So now we got that regression equation, and based on that equation, all the values of y are smoothened to these new values. So this is the example that we have discussed in the last class. Yeah. And outlier analysis is also one of the techniques for handling the noisy data. So clustering can be used for finding out the outliers. Next, data cleaning as a process, it consists of two steps. One is discrepancy detection and another one is data transformation. In case of discrepancy detection, there are many possibilities for discrepancies. So I have listed a few of the reasons why a discrepancy occurs. And next, how to detect them. We have two techniques, using the domain knowledge, and another one is using some unique rules, consecutive rules and null rules. Okay. And later, after finding out the discrepancy, we need to transform the data. So for data transformation and for discrepancy detection, we have certain tools. Discrepancy detection tools are of two types, which are data scrubbing tools and data auditing tools. Okay. And next, data transformation is performed once the discrepancies are detected. Okay, we have predefined tools for data transformation also. And one more tool for which performs both discrepancy detection and transformation is the Potter's wheel. So this is the publicly available data cleaning tool which integrates both these. Okay. Yeah. So this is our today's topic. So till now we have discussed in our last class. So in data pre-processing, we have learned what are the main reasons for pre-processing. That is a need for pre-processing. We have discussed that. The main thing is improving the quality of the mining results. So in order to improve the quality of the mining results, we need to improve the quality of the input data. So that is the main reason for data pre-processing, and we have multiple steps. One of the steps is data cleaning, what we have discussed now, and next one is data integration. Okay, so data integration means, yeah, so we are merging the data from multiple data stores. So careful integration is required. It helps to reduce or avoid the redundancies and inconsistencies in the resulting data set. Okay. So careful integration will improve the accuracy and speed of the subsequent data mining process. This data integration will help in improving the value of the business, as well as it improves or it gives better decision making. Okay, so it's used for better decision making, as well as which improves the value of the business. So finally, our target is to find out the better mining results. Okay. Yeah, for getting that output, we need to pre-process the data. So data integration is one such step where we are collecting the data from multiple stores. So there are different challenges involved in this data integration. So one is the schema integration and object matching. Next, redundancy and correlation analysis, tuple duplication, data value conflict detection and resolution. So we'll discuss each of these challenges in our next slides. The first one is schema integration and object matching. This particular issue will deal with how to match multiple entities involved in multiple data sources. Okay. We have customer-ID. So customer ID in one database, and in another database we have customer-number. Okay. So these two represent the same, that is the customer identification, but the usage of these attribute names is different. So how can we match this? So this is called entity identification problem, matching of multiple entities from multiple data sources, which is called as entity identification problem. And also, while matching the attributes from one database to another during this integration process, you must also pay special attention to the structure of the data. The structure of the data means here, there may be functional dependencies between the attributes and some differential constraints. So whatever the functional dependencies and differential constraints present in the source system, they must match with the target system. The source system means the actual data source from which we are integrating the data. Target system means the system which collects all the data from multiple sources and creating a single warehouse. That is the target system. Okay, so I mean the source system should match with that of the target system. The constraints in the source system must match with the target system. For example, if you consider a discount attribute, so it is actually applied to the order. Discount for this complete order. Whereas in some other systems, the discount may be applied to each item in the order. For each item, this much of discount is given. If you go to this Reliance Mart, after getting the bill, you can see. So for each item, they will be mentioning the discount. This item actual cost. What is the cost? What is the actual cost, and what is the cost provided by them? Okay. Next, a discount is given for each item, not for the total order. Whereas in some other systems, discount may be for the total order. So this should be found before integration. Otherwise, the items in the target system will be improperly discounted. Okay. And next issue is redundancy and correlation analysis. Yeah, when you integrate the data from multiple sources, there is a possibility that redundant attributes may be generated. Redundant attribute means when we call a attribute as redundant, if you can derive an attribute from another attribute or from set of attributes, then we can say an attribute as redundant. If you can derive an attribute A from other attribute B or from two more attributes B and C, then A is redundant. So in order to find the redundant attributes, we have a correlation analysis technique. So this helps in detecting the redundancy. So coming to this correlation analysis, to given two attributes as input, this correlation analysis will measure how strongly one attribute implies the other. There is a coefficient called correlation coefficient. Okay. So for two attributes, given two attributes, two numerical attributes, it will find out the correlation coefficient between them. It measures, correlation coefficient is the measure which decides how strong one attribute implies the other. That is the correlation coefficient. So yeah, here is the formula for calculating this correlation coefficient. So given two attributes A and B are two attributes, then we can find the correlation between these two using this formula. Here, this left-hand side of this equation. So this refers to correlation coefficient between the two attributes A, B. And here you can find n in the denominator, which is number of tuples. I mean, number of rows for which the values of A and B are considered. And next, AI, BI. These are the values of the attribute A and B. So we are having rows, n rows, A1, B1. So these two belongs to first row. A2, B2 belongs to second row. Similarly, AN, BN belongs to the last row. That is nth row. That is AI. I varies from 1 to n. And A bar, B bar. These are the mean of A, mean of B. And this standard deviation, the sigma A, sigma B. These are the standard deviations of A and B. Okay. So let's, yeah. So coming to this correlation coefficient value, this can be between -1 and +1. This value will not be greater than +1 or it will not be less than -1. According to this formula, which is calculated for two numerical attributes, correlation coefficient value, its range is -1 to +1. For any two numerical attributes, if you calculate the correlation coefficient, its value will be between -1 and +1. If the value is 0, we can say that two attributes are independent. There is no correlation. If the correlation coefficient value is 0, then both are independent. Both should exist in the database. That is the meaning. They are not redundant. They should exist in the database. Okay. If correlation coefficient is positive, that is greater than 0, then we say A and B are positively correlated, which means that increase in A will also increase in the value of B. The higher this value and stronger the correlation. Yes, the higher value will indicate that both are redundant, one attribute can be removed. If this correlation coefficient value is negative, that is less than 0, they are negatively correlated. Means the values of one attribute increase as the values of other attribute decrease, which indicates that one attribute discourages the other. Negative correlation. If one attribute value increase, the other attribute value decrease. That is negative correlation. Yeah, you can see from these plots, the first one which shows the positive correlation between the two attributes. So how we got these plots is, if you consider A, B, two numerical attributes, you plot the values of these two values on a graph. If the plot is like this, then we say as positive correlation, because increase in one attribute leads to increase in another attribute. See how the curve is growing. It's like this. The curve is like this. So increase in the x-axis, increase in the values present in one attribute leads to increase in the values of other attributes. So this is a positive correlation. And negative correlation, see, increase in the values of one attribute will lead to decrease in the values of another attribute. So this plot will show the negative correlation. And these are the different cases where there is no observed correlation between the attributes. There is no correlation between the attributes in this tree graph. You see here. So this is the middle one, which is high positive correlation, 0.9. Okay. And what is the low positive correlation? 0.5. Perfect positive correlation, which is 1. So what is the maximum value for this correlation coefficient between two numerical attributes? +1. What is the minimum value? -1. So these are the lowest and highest values. So if the correlation coefficient is 1, we can say they are perfect positive correlated. Those two attributes are perfectly positively correlated. 0.9 indicates the high value, high positive correlation. Okay, 0.5 indicates low positive correlation. Similarly, -0.5 indicates low negative correlation. And -0.9 indicates high negative correlation. And -1 is perfect negative correlation. So we know the values, possible values are from -1 to +1. So these values indicates that perfect positive correlation value is 1, which indicates both the attributes are redundant. If the value is 1, they are redundant attributes. Yeah, here we'll discuss about the covariance and correlation of numerical data. So covariance is also a similar measure as correlation. So in this probability theory and statistics, both these correlation and covariance measures are used for assessing how much two attributes change together. To consider two numerical attributes with some n observations, a1, b1, so on to an, bn, their mean values or expected values are calculated using this. Expected value of a, which is nothing but the mean. So sum of all the values of attribute values of a divided by total number of observations. Similarly, sum of all the values of b divided by total number of observations is mean of b. And now correlation is calculated based on the covariance divided by product of the standard deviations of a and b. Covariance is calculated using this formula. So what is this formula actually? We are finding out the deviation of each attribute value from its mean. You are performing the product and finally summing the each product value, sum of the products. So this is the covariance. So if it is divided with the standard deviations of a and b, we get this correlation coefficient value. Okay, we'll solve a problem. Similar to correlation, covariance also, if covariance value is positive, so positive covariance. So it indicates that two variables move in the same direction. If covariance is positive, the two variables or the attributes tend to move in the same direction. If the value is a negative, it reveals that both the variables tend to move in inverse directions. And coming to the boundary of the values of covariance, it can be any value. It's not fixed like -1 to +1 in case of correlation coefficient. Covariance value can be any value, -infinity to +infinity. Okay. So if A and B are independent, then covariance will be 0. If A and B are independent, then covariance will be 0. If it is positive, then they are moving in the same direction. Means increase in one value will also increase in another value, decrease in one attribute will also lead to decrease in another attribute. They are negative, then inverse direction. Increase in one attribute will lead to decrease in another attribute, like that, vice versa. Yeah, here is an example where we have stock prices for two companies. So here we considered stock prices of two companies. One is All Electronics and another one is High Tech Company. Here the question is, so stock prices at 5 different time points. Stock prices at 5 different time points for this companies are given. So what is the, if the stocks are affected by the same industry trends, so these are the values, stock price values for All Electronics Company, and these are the values for High Tech Company. Okay, will the prices of these two companies rise together or fall together? So what is the relation between these two? This can be found using covariance between All Electronics and High Tech. How these two companies are affected by the same industry trends. Will the stock prices rise or fall? So, yeah, covariance between these two is calculated. So what is the expectation of All Electronics? That is, if you consider this All Electronics, so its mean is calculated using all the possible values. For 5 time points we are considering. So 6 plus 5 plus 4 plus 3 plus 2 divided by 5, which is $4. So all these are in dollars. And in case of High Tech Company, its mean is 20 plus 10 plus 14 plus 5 plus 5 divided by 5, which is $10.8. Okay. So now covariance is calculated based on, yeah. So what is the formula given here? You can go through it. Yeah. So we have two formula. Actually, this can be written in simple form in this way: expectation of AB minus mean of A into mean of B. So otherwise, you can use this formula also. Either of these two can be used. Either this or this. Both are same. So find out the product. 6 into 20. 6 into 20 plus 5 into 10, 4 into 14, 3 into 5, 2 into 5. These are the products. Sum of the product divided by total number of observations, n value. Okay, minus each mean. What is the mean of All Electronics? 4. Mean of High Tech? 10.8. So this gives you, the value of this is 50.2 minus 43.2, which is 7. So what is the value of covariance here? The covariance is positive. As it is positive, we say that stock prices for both the companies rise together. If it is negative, we can say that if the increase in one, the increase in stock price for one company will lead to decrease in stock price for another company. Okay. So positive covariance will show that the stock prices for these companies rise together. I mean, change together. Yeah, so that is about correlation analysis between two numerical attributes. What about the correlation between categorical attributes, means non-numerical attributes? How to find the correlation between two non-numerical attributes? So we have one statistical test which is called chi-square test. It gives the correlation, a relationship between the two attributes, two non-numerical attributes. We call it as nominal data or categorical data, anything is same. So the correlation between two attributes A and B can be found using this chi-square statistical test. So before explaining this theoretical part, I'll give you the example so that it will be clear for you. Yeah. So here we have two attributes. One is gender and another one is preferred reading. So these are the two attributes. So now a survey is conducted among 1500 people and everyone is asked for their gender as well as their preferred reading of books. So whether they are interested in fiction or non-fiction. These two are nominal values. So preferred reading is a nominal attribute, non-numerical values. And gender is also a nominal data, female and male, non-numerical values. Okay. So now we need to find the correlation between these two attributes. Okay. Correlation between these two attributes can be found using this a chi-square test. So for this, first we have to construct the contingency table. So contingency table shows the relation, shows the frequency of the values, the frequency of the joint event, the frequency of the joint event. For example, if you consider this 250, so this 250 indicates that among these 1500, 250 are male and they prefer fiction books. That is the meaning of this 250. Yeah, let's discuss about this 90 later. First, we'll see this frequency. And this 200 indicates that 200 are female and they prefer fiction books. So 250 plus 200, total how much? 450. So 450 people prefer fiction books. And next, 50 prefer non-fiction books. 50 male prefer non-fiction books. And next, 1000 female prefer non-fiction books. 1000 plus 50 is 1050. So total non-fiction books, the persons who prefer non-fiction books is 1050. And if you count these column values, 250 plus 50 indicates 300 male were there in the total survey of 1500 people and 1200 were female. So that is the meaning of this contingency table. From the given input data, we constructed this frequencies. Okay, from the input survey, we constructed this in a frequency table, which is the contingency table. Okay. So now this chi-square test is conducted based on, this is the observed, sorry, wait a minute. Observed frequency, whatever the frequency that we calculated is observed frequency. And now we have one more term called, expected frequency. We need to calculate the expected frequency. So expected frequency is calculated using this formula. So what is this is count of actual possible values of AI and count of actual possible values of DJ divided by total number of observations. So coming to our example, we want to calculate the expected frequency of male, fiction. We already calculated the observed frequency. Observed frequency of male, fiction is 250. This is from the input data. And the expected frequency is that is calculated based on the count of male. What is the count of male? 300. What is the count of fiction? 450. So 300 into 450 divided by total number of observations, which is equal to 90. So this is the expected frequency. Okay, that we called it as E11. 11 refers to just first row, first column. That is one cell value, EIJ. Okay. Yeah. And similarly, expected frequency of female, fiction. How it is calculated? Total number of females, 1200. Okay. Total number of fiction preferred people, 450. Divided by 1500. This is 360. This one. Similarly, 210 and 840. So in this way, we will calculate this expected frequencies. So that is a formula actually here given. And now coming to this statistical chi-square test. So this is the formula for calculating the chi-square value. See, this is the difference between observed frequency and expected frequency. OIJ minus EIJ gives the difference. So we'll find out the squares. Once we get this observed frequency and expected frequency, we can easily calculate this chi-square value. Yeah, here we have done it. So this one, chi-square equal to 250 minus 90. Difference between the observed frequency and actual frequency divided by EIJ, 90, plus this one, 50 minus 210 whole square, 50 minus 210. Divided by EIJ. This is EIJ. The value in the bracket is expected frequency. Plus this one. 200 minus 360. Divided by expected frequency. Similarly, this one. 1000 minus 840 whole square divided by 840. So finally, what is the value that we obtained? 507.93. So this is the value, chi-square. This is the statistical test which is used for finding out the correlation between two nominal attributes based on the frequency of the joint event. Two attributes, right? So based on the occurrence of this event. Let's discuss this. Here you can see. Yeah. So this one, chi-square is all the possible values present in that contingency table. So it's a 2 by 2 table in our case. In our example, it's a 2 by 2 table. Why it is 2 by 2 table? Because for both the attributes, we have two possible values. For gender, we have two possible values, that is male, female. And for preferred reading also, we have two values. One is fiction and another one is non-fiction. Okay. So here C refers to number of attributes in number of values of one attribute, and R refers to number of values in another attribute. Yeah, you can see here the explanation of this is given here. A1 to AC. So these are the possible values of attribute A. C distinct values, A1 to AC. And possible values of B are given as R, B1, B2, so on, BR. In our case, I'm saying R is equal to 2, C is equal to 2. If you consider A as the gender and B as the preferred reading, attribute gender has only two values. So C is 2 in our example. And preferred reading also has two values. So R is 2 in our example. R is 2, C is 2. Okay. Yeah. And AI, BJ refers to joint event, means attribute A will take the value AI and attribute B will take the value BJ. For example, the total male persons who preferred fiction, AI, BJ. A1, B1 is male fiction. And similarly, A1, B2, male non-fiction. Similarly, A2, B1, A2, B2, like that. We have 4 possible combinations, as we have R equal to 2 and C equal to 2. Yeah. So this is the procedure for calculating the expected frequency. This depends on the actual count of each attribute value, its product divided by total number of observations. This we have calculated. And now, what to do after getting this chi-square value? After getting this, excuse me, after getting this chi-square value, somebody asked a question. Yeah, last year now, did you understood about this values in bracket? Just now I saw your chat message. Yeah, okay. So the values in the bracket is the expected frequency, which is different from the observed frequency. Observed frequency is calculated from the input data. From the input survey that we have conducted, we have calculated the observed frequency. The expected frequency is calculated based on the total possible values of each attribute. After getting this chi-square value, now we'll compare that value. So we got, in our case, we got 507.93. Yeah. Here we'll consider, in this test, we'll consider an hypothesis. Hypothesis here, it represents the assumption. Okay. So hypothesis is A and B are independent. Our hypothesis is the attribute A and B are independent. Means there is no correlation between the two attributes. I mean, we assume that we'll consider a hypothesis that A and B are independent. And then finally, based on our test result, we can either accept the hypothesis or reject the hypothesis. So when to accept the hypothesis, when to reject the hypothesis. Okay, understood? Based on the chi-square value, we'll decide whether the hypothesis can be accepted or rejected. So this depends on a term or a value called significance level and degree of freedom. You have to remember these two terms. One is a degree of freedom and another one is significance level. So degree of freedom here refers to R minus 1 into C minus 1. What is R here? 2. What is C here? 2. So 2 minus 1 into 2 minus 1 gives you the degree of freedom. And coming to significance level, see, this is a table which is retrieved from a statistics textbook. So these are the predefined values. These are the predefined values which indicates, row indicates the degree of freedom. So how the degree of freedom is calculated is based on the product of difference in, sorry, R minus 1 and C minus 1. R represents number of values of one attribute. C represents number of values of another attribute. Based upon these number of values, the degree of freedom is calculated based on the product of it. So degree of freedom can be either, it can be anything. Here I have considered only a part of that table from the textbook. I have not considered the complete thing. So this 1, 2, 3. The list, it may vary. It depends upon the number of R and C values. Okay. Yeah. In our case, we got 2 minus 1 into 2 minus 1, which is 1. So this first row is important for us. We have to check this first row. Okay. So for 1 degree of freedom, we need to check our chi-square value, whether to accept the hypothesis or reject the hypothesis. Okay. And we need to consider the significance level. We have different significance levels in this predefined table: 0.5, 0.1, 0.05, 0.2, 0.01, 0.001. So the highest, significance level, the best significance level is 0.001. It indicates 99.99%. Okay, this indicates 99.99%. Our assumption is true. Okay, this is the highest level of significance level. So in this significance level, for this degree of freedom, what is the value given in the statistics textbook? That is 10.827. This is the value given for this level of significance, and for this degree of freedom, the value given is 10.827. What is the value that we obtained? 507.93. Since our value is greater than the value mentioned here, we'll reject the hypothesis. That is the rule here. If our computed value is above the mentioned value, we'll reject the hypothesis. What is the hypothesis that we considered? The attributes A and B are independent. That is our hypothesis. Means gender and preferred reading are independent. If you are rejecting this hypothesis, what is the final conclusion? These attributes are strongly correlated. As we are rejecting the hypothesis, it means that these two attributes are strongly correlated. Means we can say these two are redundant attributes. So one of the attribute can be removed. Yeah, one question from last year. Should we consider only significance level 0.001? Yeah, this is the most accurate significance level. As you move from 0.001 to 0.01, 0.02, like this. For example, what we can say is, (0.001) is the most possible significance level. I'll give you an example. Consider okay. So what will be actually, what is the highest accuracy? 100%, right? This shows that to find the difference between 100 minus 0.001. So what is the value? 99.999. Okay. So this is the highest accurate decision. So what is the value of 100 minus 0.01? So what happens if you move on to this level? The accuracy will get reduced. Understand? If you move on to this level, for example, 100 minus 0.5. So what is the value? Right? So as you move from 0.0012, as you move from 0.01 to 0.5, the accuracy of our hypothesis will be less. So possibly we'll check for this highest possible significance level. That is 0.001. Okay, understood, Lasya? I hope I answered your question. Okay. So finally, we got the chi-square value, which is greater than this 10.827, which indicates that we can reject the hypothesis. What is the hypothesis? Both the attributes gender and preferred reading are independent. If you are rejecting means, finally we are saying gender and preferred reading are dependent. They are redundant. So actually, we are not strong in statistics, right? So the statistics people will know more about these. But for your understanding purpose, I have collected this from this statistics textbook, and then I have included this table. So this is not given in your textbook. Okay. Okay, I'll conduct one quiz later. We'll continue with the next topic. The degree of the freedom we need to calculate. Degree of the freedom must be calculated. So it's R minus 1 into C minus 1. Only if degree of freedom is calculated, then we can move on to that particular cell in that table. Otherwise, it's not possible. So we need to calculate the degree of freedom. Which calculation? Degree of freedom. Last year, are you asking about that statistic table or contingency table? Contingency table will be statistic table. Actually, that's a predefined table. If you are asked to solve a problem related to chi-square test, you will be given that table. You will be given. No need to worry. That table will be given. Okay. Otherwise, it's not possible to find out. Only once you know the table, we can find out. Give me a minute, students. I'll share you the quiz. Time is 2:15 by 2:21. I'll end it there. Last 2 minutes. Fast, make it fast. And release the scores. Please check it.
Ma'am, hello.
What?
Ma'am, I did not submit. Ma'am. There is an internet issue.
Okay.
Yes, ma'am.
Submit quickly.
Yeah, ma'am.
Check your scores. Okay. So let me discuss this. Data cleaning. Data cleaning involves removal of noisy data, resolving the inconsistencies, and also data transformation. So data transformation is one of the step in data cleaning as a process. So once you find out the discrepancies, once the discrepancies are detected, will transform the data, right? So all the above is the answer. Data integration will, yes, it will improve the value of the business and it will lead to better decision making. So both the above. Knowing the correlation between the attributes will help to detect the redundancies. Yes, that is true. Correlation analysis helps to detect the redundant attributes. And next one is correlation coefficient among two attributes can never be negative. This is false statement. Correlation coefficient can be negative, but can't be less than -1. Okay, so it can be negative. So the answer is false. To identify the highest positive correlation between any two attributes. It's 1. It's not 1.5 or 2, it is 1. It is the most possible value is only +1. Other than +1, we can't get the correlation value. Correlation value is a maximum of 1. So the answer is 1. Haripriya, no need to worry. If yours is not submitted, no need to worry. No problem. As I already said, I'll be considering best out of all. Okay, let me continue with the next topic. So one more issue in data integration is tuple duplication. So till now we discussed about the redundancy in the attribute level. So due to this integration, it is possible that redundancy can be at the row level also. That is at the tuple level. So two or more identical tuples for a unique data entry case may exist. Okay. So one of the reason for this data redundancy is denormalized tables. In order to reduce that only, we go for normalization, right? So the use of this denormalized tables is one of the reason for data redundancy. And why we use these denormalized tables is in order to get rid of this join operations, multiple join operations. So if there are more number of normalized tables, then more join operations are required, which will decrease the performance. So the use of denormalized tables will reduce the join operations, which in turn increase the performance. Okay. So use of this usage of denormalized table is another source of data redundancies. And inconsistencies often arise between the various duplicates due to inaccurate data entry or updating some, but not all of the occurrences of the data. If you have the same entry, if it is updated at one location and not updated in another location, then it's leads to inconsistency. It's a problem, right? For example, there is a purchase order database which contains the attribute for the purchaser names and address instead of a key to this information in a purchaser database. It means you have the purchaser name and address. If the purchaser's name is present at multiple locations, then the discrepancy can occur. Mean you're updating the purchaser address at one location and you're not updating the address information in another location. Then it leads to inconsistency, right? Okay. Yeah. This kind of redundancy at tuple level also may occur because of this integrating data from multiple sources. And one more issue is data value conflict detection and resolution. This means that for the same entity, attribute values differs between multiple sources. For the same entity, for example, you consider a weight attribute. So weight is a attribute for an entity person, real world entity person. If you consider the attribute weight, so weight attribute will be stored in metric units in one system and the British empirical units in another system. So the measures may vary, but it's the same. Entity is same. This is one problem, data value conflict. And if you consider price, in case of a hotel management system, price of rooms in different cities. So different cities means maybe different countries also. Okay. So it may involve different currencies and also different services and taxes. At one data store, the data may be stored in dollars. In one data store, the data may be stored in rupees. When you are integrating the data from one country data to another data of another country, so the price measure also varies, right? That is one issue. And if you consider any school or university grading mechanism, so one university may adapt quarterly system and they may offer, for example, 3 courses on the database systems and assign the grades from A+ to F. And another may adopt the semester system. Some may adopt the quarterly system, semester system, yearly system. It may vary. And grading mechanism may also vary. Some may use A plus to F. Some may use 1 to 10 grades. Grading system may also vary. And the number of courses provided also vary. It's one example. And one more is attributes may also differ on the abstraction level. Here, one attribute may be recorded at lower abstraction, whereas the same attribute will be recorded at some other abstraction level in another data store. For example, if you consider total sales attribute. So in one database or one data source, they may be storing the total sales related to one branch, whereas the same attribute, total sales, in another database, they may be referring to total sales of the region. Total sales of the region. One may be following total sales of the branch. The attribute name is same, may be same, but it's the value present in it may conflict with the other data source. So these are the different examples where the data value conflict occurs. So these are the problems that occur in data integration. So here is an exercise for you. So we have two variables, age and percentage of fat. So the question is to calculate the correlation coefficient and covariance. And you have to check whether these are positively correlated or negatively correlated. So you can use this correlation coefficient. As these are numerical attributes, you can go for correlation coefficient and also calculate the covariance. So covariance is simple, right? Covariance divided by standard deviation of two attributes. Product gives the correlation coefficient. We have the relation between correlation and covariance. So it's easy. You can try it at your home. Yeah, and the next one is, the next technique is a data reduction. This is another data pre-processing. So it is a pre-processing technique which reduces the huge amounts of data to smaller data sets. Reduces large amount of data to smaller data set. We have multiple data reduction strategies such as dimensionality reduction, numerosity reduction. Okay. So we'll discuss one by one. So dimensionality reduction means you're reducing the number of dimensions. Okay. You're converting a data set with vast dimensions into data set with less number of dimensions. Dimension is here, it can be an attribute or some group of attributes will gives you a dimension. So time is a dimension, location is a dimension. If you consider location, location may be having a city, state, these are the attributes. Multiple attributes, group of attributes will form a dimension. Okay. Like that. So data attributes or dimensions can be reduced in this dimensionality reduction technique. Because all the attributes are not required for the data mining. So we have to select the most suitable attributes. There are some techniques such as forward selection, backward elimination, decision tree induction, and an integrated approach which combines forward selection and backward elimination. So these are the four techniques for dimensionality reduction. So these are used for selecting the most relevant attributes. And the other attributes are removed or reduced. So dimensionality reduction refers to reducing the attributes or the dimensions. Next, one more reduction technique is numerosity reduction. So here this technique will reduce the volume of data by choosing smaller forms of data representation. So the data will be represented in some other form, simpler form, so that the volume of the data is reduced. So we'll see with examples, don't worry. So numerosity reduction can be done using histogram technique, clustering, or sampling of data. We have three techniques for numerosity reduction: histograms, clustering, and data sampling. Okay, means it will replace the original data by smaller forms. For example, if you consider age, so for age we have multiple values, right? Many values will be there. If you convert this age to categorical, such as youth, middle-aged, senior, then we have only three groups, right? We have only three groups. Possible values of age may be more than 100. All these 100 values can be grouped to any of these three values. So you're forming some other representation. You're replacing this original data with some other smaller forms of data representation. So that is numerosity reduction. And one more is data compression. So here we'll perform the transformations to produce the compressed representation of the original data. Okay. Actually, in this compression technique, large volumes of data will be compressed, means the number of bits used to store the data is reduced. The number of bits used to represent these data will be reduced. That is the compression technique. So it can be lossy compression or lossless compression. So lossless means, yeah, after compression, you are getting the compressed data, right? So from this compressed data, if you can reconstruct the original data, then we say it as lossless compression. The other one is lossy. From the compressed data, if you can't retrieve the original data completely, then we say that reduction as lossy compression. Have these reductions. So this is attribute subset selection. This is one of the dimensionality reduction technique. Attribute subset selection. Okay. So it reduces the data set size by removing the irrelevant or redundant attributes. We have four approaches here. One is forward selection, and another one is backward elimination, decision tree induction, and last one is combination of forward selection and backward elimination. So in case of forward selection, in any of these techniques, the initial input will be list of all the attributes present. Initial attribute set will be all the attributes. A1 to A6. In our example, if you consider attributes A1 to A6, this will be the initial attribute set. And if you consider the output set must consist of only reduced set of attributes. Reduced set of attributes means whatever the attributes that are relevant, they are only selected for the output set. So according to forward selection, the output will be initially empty. So all these are iterative approaches. Okay, initially, the reduced set will be empty as shown here. Okay. And at every step, we'll find out the best attribute and add it to this output. Here, in this case, among these A1 to A6, A1 is found as the best attribute and it is included in the attribute set, output attribute set, which is called the reduced set. And in the next step, among the attributes A2 to A6, A4 is found as the best one. It is included. A1, A4. And now, how many attributes are remaining? A2, A3, A5, A6. Among these four, in the third step, third iteration, A6 is considered as the best attribute. So, A6 is included. Okay. So, how this A1 is selected, A4, A6 is selected? The criteria will change. There are many attribute selection techniques we'll learn in our third unit. In third unit, we'll learn how an attribute is selected from the given data set, which attribute is selected at this level, at this point of time, which attribute is selected. So we have some measures such as information gain, gain ratio, Gini index. So there are different techniques for selecting the attribute that we'll discuss at that while discussing the third unit. But here is the general procedure of forward selection, how the forward selection works. So initially it will start with an empty set, and later at each step the best attribute is selected and included in that output set. Okay, and when to terminate, everything will be according to that criteria, how we are going to select the attributes. And next, backward elimination. In this technique, initial output set starts with the input. Input is same as output. In backward elimination, input is same as output at the first step. And later, we go on eliminate the irrelevant attribute at each step. At each step, you eliminate the irrelevant attribute. So among A1, A2, A3, A4, A5, A6, here A2 is found as the irrelevant attribute. So in the first step itself, A2 is eliminated. And in the next step, excluding A2, in the remaining attributes, that is A1, A3, A4, A5, A6, next irrelevant attribute is selected and it is eliminated. That is A2. Sorry, A3. And now we got only A1, A4, A5, A6. So in the next step, you're going to eliminate the attribute A5. So finally, we have only 3 attributes. So the actual procedure of backward elimination is the output starts with the initial input set, and at every step, we are going to eliminate the irrelevant attribute. That is the procedure of backward elimination. And the hybrid approach is combination of both forward selection and backward elimination. In this approach, both the steps are done parallelly, both forward selection, backward elimination. So at every step, we are going to select the best attribute and include, and we are going to eliminate the worst attribute or irrelevant attribute. Both are done at the single step. I mean, at every step of the iterative process, these two were considered. That is hybrid approach. And next one is a decision tree induction. So this decision tree induction is a technique that is used for classification. So this can also be used for finding out the relevant attributes. So if you see here, this is a tree constructed. So tree means it will be having a root node and internal nodes and leaf nodes. So at every stage of tree construction, we need to select an attribute. So an attribute is selected and it will be decided as the root. The first attribute that is selected will be considered as the root, and based upon the condition that we apply for the attribute. So we are here, A4 question mark indicates certain criteria. Certain criteria is applied such that it may result in yes or no. This